Hi, this is Jake, and today I'm going to be talking to you about OSSMO. So OSSMO is an open source software package that I developed, which enables open source software users to help sustain the open source software projects that they use. And the way that it works is the users, when they install the open source software package that they're going to be using, the package asks the user if it's okay to download and run a cryptocurrency mining software. And then the cryptocurrency mining software connects to a mining pool, and it tells the mining pool on behalf of which open source software package the user is going to be mining. And then the mining pool sends cryptocurrency to a wallet address. And then there's a daemon which watches the wallet address. And when it receives a transaction, it checks the mining pool for statistics about how much hashing power was contributed on behalf of each open source software package. And it uses that information to calculate how to split the incoming transaction among the authors of the open source software packages that contributed hashing power to the mining pool. And here is a rough diagram of how that works. And I am going to dive right in. So the first person who's likely to use OSSMO is the open source software developer who wants to enable their open source software package to mine for cryptocurrency. So I will show you how a Node.js module author is able to osmoify their package to enable it to mine for cryptocurrency. So I have this test package prepared called my OSSMO enabled test package. Oh, and I'm going to wear this hat to illustrate that I am the open source software developer user. So I have this test package prepared called my OSSMO enabled test package. And it's a very simple module. It exports one function, which calls console.log. And I'll show you how to enable this package to mine for cryptocurrency using OSSMO. So there are three things that you have to do. The first one is in your package.json, add the OSSMO client as a dependency. Then, in your main module, require the OSSMO client. And as an argument, to initialize it, pass it the package name. Finally, the last thing you need to do is you need to add a tips field to your package.json of the following form, where each key of the object is the email address of a package or maintainer, is an email address of an author or maintainer, and then each key of that object is a BTC, a Bitcoin address, Bitcoin wallet address. So this package is published in NPM, and I am going to switch hats and show you what it looks like from an open source software user's perspective. So now I'm an open source software user, and I'm somebody who would like to use the my OSSMO enabled test package. So I'm going to initialize my project. Call npm init to initialize a new project. And I'm going to install my OSSMO enabled test package as a dependency. Okay, that's installed. I'm going to create an entry point, index.js module, and require this package. Call F. Now I'm going to run the module, and we can see what the onboarding workflow for the OSSMO client looks like. So you can see here that it's prompted the user. For completeness, I'm just going to read what the text says. Hi, it looks like this is the first time you're running OSSMO, my OSSMO-enabled test package. My OSSMO-enabled test package is supported by the community of its users. You can help sustain this project by mining for cryptocurrency on your computer. The mining process runs in the background with low priority so as to not disrupt other processes, and 100% of the cryptocurrency mined goes toward the project authors, minus network fees. Would you like to help support this project by mining for cryptocurrency? Say yes. Great. We will now download the mining binaries onto your system. Note that some antivirus software may flag these binaries as malware, but it is not malware. Is it okay to download this software now? Say yes. Okay, one last thing. You can choose to mine anonymously, or you can report your NPM username to the mining server so that you and other people can see how much hashing power you have contributed. Would you like to mine anonymously? We'll say no. Okay, and just like that, it downloads the binaries and it starts hashing. So I'm going to switch hats one more time, and I'll show you what things look like from the perspective of the OSSMO system administrator. So you can see what happens when the system processes hashes and then processes payments. Okay, so the first thing is the mining pool. This is the dashboard of prohashing.com, which is the mining pool being used by OSSMO. And you can see that the user, which has just joined the mining pool, this is my username, my NPM username. You can see it's reporting statistics to the mining pool. Furthermore, it's also reporting the name of the package on behalf of which it is mining. It looks a little funny here because the mining pool doesn't allow you to use special characters in the name of the group. That's why it has these U followed by numbers followed by underscores. But you can see here it says my OSSMO enabled test package. So after sufficient hashing power has been contributed to the pool, a payout threshold will be reached, and then Bitcoin will be sent to the OSSMO wallet address, which you can see here. So it'll take some time for that threshold to be reached, probably a few more days. So in the meantime, I will simulate a payout from the mining pool by using my Coinbase account, which has some a existing balance of Bitcoin. So the last part of the system is the daemon, which monitors the Bitcoin wallet to receive payment. So every time the wallet receives a new transaction, the daemon will see that and query the mining pool for statistics about how much hashing power was contributed on behalf of each package. and then split that transaction among multiple package author Bitcoin addresses. So I'm going to simulate the payout from the mining pool using Coinbase, and we can see what the daemon does. Okay, so first I'm going to just copy the wallet address, the OSSMO wallet address. Click on send. Give it a small amount of Bitcoin, about $4 worth. Click continue. Do the two-factor authentication. And I'll go to the daemon, and just like that, it receives the transaction, and then it installs the package, my OSSMO enabled test package. It installs it in order to fetch all of the recursive dependencies for this package. So the goal is not just to compensate the author of the packages that have enabled OSSMO, but also to compensate the authors of the recursive dependencies of the packages that have enabled OSSMO. So you can see in the next line, it found all of the project authors with Bitcoin addresses in the package.json file, and then it computed the average statistics for the hash rate contributed for each package and the share that will be contributed to each package as a percentage. Well, this should say 100%, but because there's only one package in here right now, it'll be 100%. Then it prepares the transaction. So this is the address it'll send to. This is the amount of Bitcoin it wants to send. Remember, the amount of Bitcoin in the transaction that was sent to the wallet was the same amount. So the wallet, the OSSMO wallet, is really just a pass-through. It doesn't keep a balance. It attempts to disperse the transaction to the open source software authors fully. Then next it computes the fees required to send the transaction, and it subtracts those fees from the amount to send. And then finally, it sends the transaction to the Bitcoin network, and we end up with a new transaction ID, which we can then plug into a block explorer like the following. And we can see that 0.0097 Bitcoins were sent to my personal wallet address. So in conclusion, I'd like to thank the Bridge Academy for giving me the opportunity to learn about blockchain and complete this project. And I'd like to thank you for watching this video. Have a great day.